He's F4WBY.
That's correct.
And he's going to present make a presentation on QRPing with software-defined radios and operating portable. Paul, if we handle it like we did the other one, where you watch the latecomers and I'll watch the chat room, I think that'll work out okay. Thank you. Gil, go ahead.
All right, so I don't know how I can share my screen. I have to find that out. I'm not very familiar with this software. Oh, share screen, it's a big button here, of course.
Down at the bottom, I think.
Yeah, sure is. Share computer, optimize, okay. Share, whiteboard, don't know. Okay. Ask me to change the preferences. I don't have that many slides, but that'll be helpful. And it will mostly be, well, I'm not an SDR expert, but it will be mostly, I guess, portable operations. But I have used SDR radios like the Aircraft KX2 and recently the QRP Minion SDR. All right, so, okay, of course, my Macintosh is pretty old. And that should do it. Oh, here we go. You guys see anything?
There we go. Your slide is up.
Okay, all right, so am I up?
Yes, you have the portable QRP with SDR.
All right, but I'm not full screen here, so you probably see, I don't see what I'm sharing. Am I sharing the whole application or just the slide?
You're just sharing one slide right now, but the application, okay. The other slides are down the left side. So I think you just click on them.
Right, but can you see the other slides or can you just see the main one? The one that's up?
I can see the other slides on the left margin.
Does it help if you click play?
If I do what?
Click play, the play button.
Let's see, view, slide on. No, whoop.
Slide, yeah.
I can put slide only, I guess. Yeah, I don't see what you guys see, so I don't know.
There's a play button next to Keynote Live.
What? A play?
Play.
Oh,
play.
I'm not hearing what you're saying.
Sorry, click the play button.
Play. Play, P-L-Y?
P-L-A-Y.
P-L-I-Y.
P-L-A-Y.
I don't see that. I don't see that.
No, there it is. Yeah, you were there. That's it. Play.
P-L-A-Y.
Yes.
All right, very good. Now I can see it. All right, so portable QRP with. So are we ready? Are we going?
Yes.
All right.
I think so.
All right, let's do it. Portable QRP with software-defined radios. And by the way, so it's Gil, and I'm the radio prepper on YouTube. You guys who aren't subscribed can go now. Just kidding. You can stay. Yeah, you can stay. You can go subscribe later. I'm going to move to the next one. Of course, it's not going. Whoop, okay. So I've used SDR radios, and SDR radios, of course, are a recent development. I may say. The first one that I was, actually it was the KX3, which is also an SDR radio. This is an Aircraft KX2, so a portable radio. It is an SDR. Now it's not exactly what we think of as an SDR because of course it has all those buttons and it has all the controls on the radio. The difference, of course, is that all those controls are programmable and they can do different things. Same thing for the screen. The screen is programmable. It can also display different things. So this is an example of a modern SDR, but they also exist in different format. Here, for instance, next one. Okay, here's the KX2. So here's a portable situation. With the KX2 Pelican case, I power that with 3 18650 cells. Those you can find in all the laptop batteries, so they're pretty much free. And they give you about 12.6 volts maximum, and they have a good capacity, Ken key and a few other things. So KX2 in its, well, I can say natural environment maybe. And here's another radio, amazing little transceiver, not without faults, but really interesting is the QRP Minion SDR. So as its name implies, it is a software-defined radio, and it does offer some really interesting advantages compared to a regular radio or regular receiver. Now, I'm not actually a big fan of software-defined radios for different reasons, but they do work pretty well, even for portable. Generally, you see more complex radios like the, of course, the ICOM 7300, for example, which is an SDR, or the 705, which is going to come out, and that's also an SDR, but it is a portable radio. Here is an example of what we normally think of as a software-defined radio, and that's a Flex 1500. And of course, you can notice there that immediately something becomes very apparent, is that there are no controls on this box. So you have to connect it to a computer and run a software in order to use this radio. Now, of course, for portable operation, that's a bit of a hassle, because you have to carry a laptop or maybe a Raspberry Pi and run that software on it. And there are a number of softwares that you can run. But the radio will not work by itself. Basically, there's nothing you can do with it. You can control it. So you're pretty much out of luck there for portable operation. So this would be mostly, I would say, probably a radio that you would just use at home. All right, so here's an example of the kind of software that is used for SDR radios. And I'm sure you've all seen this kind of programs. This one is HD SDR. And there are a number of them. You can run them on all OSs like Windows, Mac OS, and Linux, and the Raspberry Pi. So a lot of them are free also, so that's really not a problem. The advantage, of course, you can see immediately here that you can have a look at the whole band, or a big chunk of the band, which allows you to see signals and locate signals in the band. The little Minion SDR that I showed you, by the way, does have a waterfall and a spectrum display in that little tiny, on that little tiny screen. And that's really one of the advantages of software-defined radios, that you can have all those extra features that the regular radio wouldn't have. Okay, so here's the super heterodyne receiver. That's not a new sexual orientation. That's that's a radio architecture. So we have the RF stage. So that stays. That's of course, there has to be an RF stage and a preamplifier, and we are getting those RF signals, the detector, and that that doesn't change. That's the same for any kind of radio. So we are not actually. Oh no, that's the super heterodyne. Okay, so I was already ahead of myself here. So RF stage, the frequency is then, the frequency received is then mixed with a local oscillator, which mixed to that frequency will result in a intermediate frequency. Now, I'm not going to go into details because I'm not very deep into electronics. So I'm a kit builder. I'm not a radio designer or an RF engineer. So I don't quite know what I'm talking about here. But That's why I chose actually to use a block diagram instead of the actual components, and that would have been a big schematic. Now, of course, after that, we have an amplifier for the intermediate frequency. We have a demodulator, which going to be, of course, demodulate AM, SSB, depending on the filtering that's applied to it. And then that is outputted to an audio amplifier. Here we also see the AGC, which is the automatic gain control, which is a system which will control spikes in volume, basically to protect your hearing and make it more comfortable to listen to. So quite the super heterodyne is probably the most common of receivers, along with the direct conversion receiver. Now we go to the software-defined receiver, and we can see here immediately that it's quite different. We also have an RF stage on the left, so signals come to the antenna, are detected by the RF, well, they call that an RF tuner, but. And then that signal will be converted, and ADC means analog to digital conversion or converter. So basically at that stage, the signal will be converted to digital, and nothing else is done to it, basically. And that then it enters the basically the software part of the radio. So that's controlled by either a personal computer or by a computer, basically, which is built in the radio. Then we have all kind of digital, so you have digital oscillator, digital mixer, low pass filter, all that is done by software, basically. So the advantage, of course, is that all that can change. It's not set in stone like in a regular radio. And I can't see the right of it there, but basically after that, you have digital signal processing. And that's also a great advantage, although that can be added to regular radios as well. But the digital signal processing is much easier to add to a radio that's already digital, of course. And that allows to basically reduce the noise level. And for portable operations or for any kind of really receiving, what's important is not really the power. It's the signal to noise ratio. And what you want is a big difference between the signal you're receiving and the floor of the noise, because that's what's going to allow you to actually, make sense or, decode the signal, or if it's Morse code or SSB, that's going to allow you to basically hear what's going on and be able to make contact. So what software-defined radios do really well is to lower the basically the floor level, and that's a big advantage, and that's quite an increase in performance actually. Now here are the pros. Well, what I consider, that's my opinion, of course, and I'm sure you could add or not agree with everything I put in there, but first pro is, of course, high performance. Those radios are usually quite good. Of course, they are, they're not cheap either, so we would expect them to be to have decent performance. And they're customizable. Now, the KX2 I showed you, for instance, you can change the function of some buttons. Really, if you wanted to, if you were the designer, you could change the functions of all the buttons and make them do whatever you want. And that's really an interesting concept. Even more so for radios that don't have buttons, because of course then you can just create buttons in the software and you can make them do whatever you want as well. So very extremely customizable by the designer and sometimes to a certain extent by the user as well. Now that of course can add a little bit of complexity, but that's in the cons, so I'm not going to talk about that right now. Firmware updates, that's something also that's a big advantage of software-defined radios, is that you can update the firmware, which is the software that's installed on the built-in computer for these radios. And that allows to add feature features, correct bugs, because of course it's computer system, so you can have bugs and you can have problems. That's why it's probably a good idea to, you know, not always be the first, the first adopter, so to speak, and wait a bit maybe before buying a radio. But you can, you know, actually rest assured that, you know, most problems can be solved by a new firmware update. And sometimes people will ask for new features, and those features will be added later in the firmware. Most of the time that's done via a USB cable connected to your computer. So you download the firmware, you upload it to the radio basically, and it loads it into its memory, and you could have basically pretty much a brand new radio once you change the firmware. But I mean, most of the time, of course, those are incremental upgrades. Now, I've mentioned this already, quieter with digital signal processing, and that's a big advantage. And when I say quieter, I say sometimes I've had my KX2 on, or the Minion SDR, and I've actually thought that I had a problem with the antenna because I couldn't hear the hiss, you know, of the HF, and I was wondering, you know, is this radio working, and with some, you know, is there something wrong here? What am I, you know? And of course, this just was that there was no signal at the time, and then you turn the dial and you come upon a signal, and boom, you know. So they're very quiet. And that's, you know, for long sessions of listening with the little earplugs or earphones, it adds a lot of comfort, you know, especially if you have people with you that, you know, don't necessarily like radio or don't like to hear that hiss for hours on end. It's a good option because it's much quieter. Now, of course, waterfall and spectrum displays. Now, at first, I thought that wouldn't be very useful for portable operations. And actually, I'm not a big fan of screens at all. I like radios with no screen. And so having a screen already for me is not something that's, you know, because the reason is mainly because you can't always see them well, and also you can damage screen, and it's often a point of entry for water or, you know, rain or anything like that. So dust, and I even once had ants get into my K1 as I was operating. Ants were crawling inside, you know, and I don't know, they might still be in there, but it's still working, so I haven't checked. So the display, though, the waterfall is again very useful to identify signals, and allows you to well, just find them basically, and that can save you a lot of time, just you know, turning the dial, because you have a few kilohertz of display, and sometimes for some radios a very wide bandwidth that you can work with and you can see on the screen. So that's pretty darn useful, I would say. That's very good. More screen display options. By that, I mean that you can display pretty much anything you want on the screen, like, you know, power output, SWR, you can have a second VFO, you can have a lot of things, and sometimes you can change those items or remove them or add other ones. So you can, on some radios, customize the display to your liking, basically. And that's very good too. They are cheaper for complex radios. What I mean by that is that, of course, if you have a little tiny radio like an SW Plus from Dave Benson, for example, or something, you know, very simple, like a you know, a very simple kit, it's not financially interesting to have an SDR radio, because you add a lot of components, and of course it increases the price. But for very complex radios, like, you know, you take, for example, an Elecraft K3 or something like that, that actually does make the radio cheaper because all those components don't have to be recreated in analog form. You do have, of course, software costs because you have software development, but that's another story. So here are the pros, which I consider to be the main pros for the software-defined radios. Now we're going to see the cons. And the first one I can think of, and I'm a big fan of simplicity. You know, I like very simple stuff, simple radios, because the more complexity you add, the more failing points that you can add to the system. Of course, today the surface-mounted components are very reliable, but still, you do add points of failure when you add complexity to a radio. I didn't mean by inherent complexity, I didn't mean necessarily complexity to the user or even to the designer, because I think those radios are sometimes, and you know, I would say often easier to design from a designer, from an RF engineer standpoint, because of course a lot of those integrated circuits have everything packaged in a little tiny box with the pins sticking out, and if you follow the manual, you can pretty much you know, put a few modules together and end up with an SDR. And that's not always an advantage for the user, because of course it means that someone who's not an RF engineer could just create an SDR that you know, somewhat works, put that on the market, and you know, problems would surface later, but that's another story again. But inherent complexity is to me is a con, because it can always lead to complex failures that are not always easy to troubleshoot, and that you might not be able to troubleshoot because you know, you're not a programmer, or you can't access those circuits that's in you know, those that are inside integrated circuits. Current draw is not a huge problem. Those radios, like you know, my KX2 was drawing about 175 milliamps. The Minion SDR was drawing about, I think about 200, 230 milliamps. So those are not big numbers for people used to QRO radios. But they are, you know, larger than radios like the K1, which on receive, my K1, I think sips like 50 milliamps, that's 50 milliamps. My Weber MTR3B, I think about 30 milliamps on receive. So that's, you know, quite a few times less than, you know, something like even a KX2. But for an SSB radio, it's not bad at all. It's, you know, it's not that much. There are radios on the market today that will draw, you know, 1 to even 2 amps on receive, and as soon as you key the mic, your wires melt, because it's you know, it's drawing 30 amps all of a sudden. But my MTR3B for instance, for a 5-watt output, draws about 700-800 milliamps. So that's very efficient. Of course, the SDRs with all those circuits inside, and you know, digital signal processing, and you know, maybe a color screen and all that stuff. Well, it adds up. It adds up, and you know, if you don't want to carry a lot of weight for portable operations, that's important. And when I say portable operations, I don't necessarily mean getting out of your car and, you know, to the park bench 30 feet away from there. And, you know, I mean, if you're really hiking and taking those radios in nature, and some people will, you know, for SOTA activations will climb mountains. You climb a mountain, the difference between a radio that weighs 5 pounds and one that weighs half a pound is quite a bit significant. So you would be tempted to throw it away over a cliff or something. So current draw, that's important for portable operations, and SDRs do not have the upper hand for that, I would say. Also, something that I found to be a problem, not with all radios, but for instance, the Minion SDR had a big problem with sensitivity to stray RF currents. common mode currents. And those can be created by using, you know, especially random wire antennas. You have a stray RF that comes on the shield of the coax, and that can really wreak havoc on those integrated circuits, and it can just destroy your modulation. And people won't understand a word of what you're saying, and you're just going to be transmitting a incoherent signal, if I can call it that. Or for Morse code, you know, using CW, your key might just sound, you know, just go crazy, basically. And that does happen, and it's due, of course, to, you know, this, again, inherent complexity of SDR radios. The more components you add and the more integrated circuits, the more chances that stray RF current can affect them in a negative way. Never in a positive way, anyway. All right, so the need for a separate computer, and again, we are talking about portable operations. Of course, if you're at home, it doesn't matter one bit. But if you're in nature, that's one more thing that you have to power. And of course, it's possible. You can see, for instance, Julian's channel, OH8 STN at Survival Tech Nord, is an expert in digital modes. And he packs computers and tablets in the field and does it really, really well. So it's possible. Again, I like the simplicity of simple radios like tiny QRP CW rigs, and simple even SSB radios. But I don't like to carry a computer with me. It's not something that I just want to bother with, so to speak. So the only SDRs that I've bought for myself and used did not need to have a computer connected. They're also more expensive for simpler radios. So if all you need is a simple CW monoband rig, you don't need an SDR for that. It wouldn't make any sense really to have an SDR. And so it's at that point SDRs are mostly the SDR concept is mostly used for radios that are at a certain level of complexity, once again, and features and performance. Although I wouldn't say received performance, except for the lower noise level, but you take something like an Allocraft K1, which is fully analog, and you have an absolutely incredible performance there, and it's not an SDR. So it's not only SDRs that you don't really need an SDR for performance, but it's certainly easier on the ears. All right, so antenna considerations. And first, like I said, avoid random wires. And when I say random wires, I mean any wire that's not a half wave. And most of the time people use random wires with a 9-to-1 unun. So it's basically you get any wire that's not a half wave is going to have an impedance of a few hundred ohms, and with 9-to-1 you reduce that to close to 50 ohms anyway, and with a tuner you can get it perfect. But you do have, most of the time, you are going to get some stray RF current on the coax shield, and that again can cause a lot of troubles. On the other hand, dipoles, inverted V's, and any antenna that's well balanced is not going to create those problems. So that's what I would suggest to use. Although my favorite antenna is the half-wave and fed antenna. For the good, and that's with a 49-to-1 or 64-to-1 transformer. And for that, I use the FT140-43. I even went down to in size to the FT82-43. That's a really tiny transformer. But it doesn't seem to be affecting performance. Most people use actually a stack of 2 or 3 FT240-43. That's a much bigger toroid. But those antennas are very easy to, they're very practical, basically. They're very easy to string up, and you can just have I have a 12-meter mast spider beam, and I just use that and install my antennas vertically, or for 40 and 80 meters as an inverted V, but they are half-wave unfed antennas. Use an RF choke if needed, and I would say definitely if you're not using it, have one with you because you never know, when you're going to have RF and when it's going to be a problem. In some places, depending on the nature of the ground, it's not going to be a problem. Depending on what's around your antenna, you might have a problem or not. And I have radios and antennas that some days when I pair them, in some places I have problems. So always have an RF choke when you go portable because you don't know when you're going to need it. Of course, you can always make a loop with your coax and make what's it's called a dirty balloon, but it's not called a dirty balloon for no reason. So it's not very. I don't know. I don't like to do that. I like to have a neat little box with a toroid inside and a nice little RF choke. And of course, lastly, and here I'm talking mostly about portable operations, we are dealing with low power, and it's to use a good coax. And I use LMR 240 UF. UF stands for ultra flex, but I think instead of having the regular LMR and the ultra flex, they should have had the ultra stiff and the regular because it's not that flexible. Same goes for the RG316, and that's one of my favorite coax also. It's much thinner. It's about the same size as the RG174. It's not as flexible, but it's more durable. Thin coax like that I consider to be consumable. Those cables are not going to be not going to last forever. So after a couple dozen outings, usually you're going to change your cable because it's going to be have kinks in it, or it's just going to you get a problem with the connectors and things like that. And those are really it's not just for SDRs. I mean, those advice there goes for any kind of radio. So other portable operation concerns, of course, we have reliability, ruggedness, and those radios are not, actually there aren't really any commercial radios on the market, except maybe for the that new Lab 599 that just came out. But otherwise, most commercial radios are not meant to be used outside, even if they're supposed to be SOTA and portable radios. You take the KX2, for instance. I wouldn't take my, I always was afraid to actually take my KX2 on portable operations because it's so expensive. It's an awesome radio. I sold it, unfortunately. I should have kept it. But I sold a lot of radios. I regret having sold. I'm on my third K1, by the way. But an important concern for, of course, portable operations is reliability and ruggedness and waterproofness. But again, no commercial radio is really rugged. It's just not, and of course, I also use military radios. I'm a big fan of the PRC 320. And I have quite a few also military radios on which cover 6-meter FM, most of them 30 to 76 megahertz. And those you can run over with your car or throw them in a river and they'll wait, they'll work just fine, but they're super heavy, so. And I wish we had manufacturers that would take this need into consideration and actually start building and selling radios that are rugged enough to be taken outside, because we don't have any. All right, so current draw, I mentioned that. I think that's a very important concern. For me, I tend to avoid radios that for QRP CW only radios draw more than about 100 milliamps. And for SSB radios, I set my limit to about 250 milliamps, and that's on receive. And that's just because I don't want to carry a big battery. I like I like tiny battery packs, and sometimes I use 8 AA cells, which, imagine the size of that. It's really ridiculous. Or I use 3 18650 cells, and I can put those in my short pocket, and I can operate for days with that. So the weight, I talked about that. The simplicity also. Portable operations, I'll say, almost requires simplicity. You can get away with using complex radios with a lot of stuff around it, but most of the time, that's good if you just go operate for a day. I've been out camping for a week at times, and even more, a couple weeks. And if you have something that's complex to use, you're always going to have something that's going to go wrong. And so simplicity is a big advantage. Keep it simple. Okay, efficiency. And here, that's why I'm a big fan of actually CW mode for sound Morse code, because it's very efficient. It's not the most efficient, because of course today we have digital modes that can detect and decode signals 20, 24 decibels before the noise level. So CW, you can't do that because of course you're using your ears, but it's much more efficient than SSB, for instance, which an SSB in itself is quite good, of course, if you compare that to AM or FM. But the name of the game here is to reduce losses for QRP operations, portable. So again, good coax, good antennas, resonant antennas when you can, avoid tuners. You always lose something in a tuner. You don't have to, So I tend to avoid tuners as well. I have a few, but I have an aircraft T1, for instance, and I like the ZM2 tuner, manual tuner. Then we go to size. Once again, if you're hiking, a small size radio is really an advantage, because you have to carry other stuff with you. If you have camping gear and stuff like that. I, for instance, spent a couple of weeks in the Pyrenees carrying all my camping gear and the radio gear, and I had about 50 pounds, 55 pounds of gear on my back, and it was way too much. And I should have really, and I had which radio? Oh, I had my MTR3B with me. I don't think I had my KX2 at the time. I had the MTR3B, and but I have a heavier antenna, and it's just the smaller the better, basically. My MTR3B I can fit in my short pocket, or you have radios like I just happen to have on here, like QCX. This is a monoband 30-meter CW rig. And I could have used a plastic box, to reduce the weight, but this is aluminum, and I probably have about 35 radios. So lots of them portable, of course, and lots of them were kits that I built, because not because I especially like to build kits, but because if I want something that's really tiny and small and light, and you don't find those radios. You can find very few tiny QRP radios on the market already built. Most of them you have to buy as a kit. But fortunately, we have radios like the MTR3B, for instance, that came out and sold by LNR Precision, and Steve Weber designed those, and you can buy them already made. But most radios you have to build as a kit. Then, of course, the last concern would be the cost, and of course, for me, it is because, being an amateur radio operator, I'm always broke because I buy so many radios, and of course, cost is a concern, and redundancy. I'd rather have two simple small radios than having one big complex one and a heavier one. For instance, I was always interested in the FT, the Yaesu FT817 and FT818, because you have VHF and UHF, but you can't listen to those at the same time. And of course, if the radio, something goes wrong with the radio, you lose your UHF, your VHF, and your HF. So I'd rather have more simpler, smaller radios than one big one, so to speak. And that's for redundancy. Of course, I'm the radio prepper on YouTube, so that's more a prepping concern than a portable operation concern. But redundancy is important to me, at least. And that's it, guys. And that's a nice photo a friend of mine took F4WBY during our last radio outing. And you can see here that we have quite a few antennas up, and that's of course in the south of France and at the Plateau de l'Authion, 2,000 meters altitude. And of course, that's really, we can make a lot of good contacts given the height there. All right, and that's about it. So we're going to go with the questions now, if you have any. And I'm going to hand back control here. Oh, I have someone. Can I click to admit here? Whoop. All right, so go ahead, guys.
Thank you, Gil. Informative presentation there. The way we're going to handle questions is take your questions and put them in the chat room.
Oh, let's see. Can I see the chat room? That's a good question.
Well, even if you can, I'm going to read the questions off. So if you'll put them in the chat room, starting right now. Now, I don't speak French, so if you put a question in the chat room, Gil will have to answer it.
I'll translate if needed.
Okay. Gil, can you see the chat room?
No, not yet. I'll find it, but
now down at the bottom, I think it says. I think you'll find chat.
Oh, chat. Okay. Yeah. All right.
Open that up.
Yeah.
And if you can see it now, we may just let you answer the question. How's that?
Oh yeah, there is a French Didier. Merci pour cette belle présentation. Okay. All right. Thank you, guys. Do not think that the SC705 will be a game changer. Portable ops. For some people, yes. For regular portable ops, yes, certainly. I'm sure it's an excellent radio. I'm a big fan of ICOM. For me, for prepping purposes, and I'm saying prepping. I don't mean hardcore survivalism. I mean just being prepared for the unexpected. The 705. Again, I'm not a big fan of large screens, and it's a little bit expensive for my wallet. Although I did buy a KX2, so but I don't think I will buy it because I'm not. I want to wait a bit maybe and see if it's rugged enough for portable operations. So a game changer, yeah, for some people, yeah. For SOTA maybe, and for me probably not. All right, what is the main difference in operation between a 49 and 60? Well, it is of course, a 49-to-1 transformer, you divide the impedance by 50, and the 64-to-1, you divide the impedance by 65. But there isn't really much of a difference because when you get to a few thousand ohms of impedance of a half-wave wire, whether you divide it by 50 or 60, the result is going to be pretty much similar. So it doesn't make for big of a difference, a lot of difference. But the fact is the 64-to-1 has more turns usually, and that's better for the lower bands like 40 meters, 80 meters. I would rather use a 64-to-1 for 40 or 80 meters, and maybe a 49-to-1, 6 to 40 meters, 30 meters. That's about it really. Otherwise, it's pretty much the same. How does the QCX compare with your SDR portable radios? I really like the QCX, and actually Hans Summers just released a new one, the QCX Plus, I think, which is a little bigger actually, but I'm probably going to get another one for 30 meters. I really like the QCX. It has a little bit too much current draw for me, but it's, you know, it has a lot of features. It's a really good radio, and I'm really happy with it. So actually, I have two of them. I have one for 30 meters and one for 80 meters. How it compares with the SDR radios, performance-wise. It's probably the same as the Minion SDR. It's not a KX2, of course, but it's really quite good. It's really good. It has really good performance, and yeah, I really like the QCX. Big fan of it. Radio Prepper is a great channel. Very good. MCHF, no, I haven't tried the MCHF. I can't buy them all, unfortunately. I wish I could, and I buy a lot of radios, but I just don't have the money. But you guys can go to my Patreon account, and maybe I can buy a couple more. All right, so no, I haven't tried the MCHF. I'm very interested in the Lab 599, or yeah, the new one that just came out there, but do you see a benefit from using Litz wire? I don't know what Litz wire is, so I don't know. I don't know. I use magnet wire, just what I call, you know, magnet wire. He's also planning a QCX Mini. Oh, okay, cool. Wow, that's interesting. That would be awesome. Yeah. And I've been talking to him, but he didn't mention that to me. He mentioned other things, but I can't say. All right, let's see what else we have. Maybe about, it's large ESMD, yeah, I guess, yeah, I bet. All right, Litz wire has many very thin conductors, is one of the threads. I don't think that's necessary for a transformer. I don't think it's even desirable, but I use on the FT140-43, I use 1 millimeter wire, and on the FT82-43, I use 0.7 millimeter wire, magnet wire, and but I use very thin wires for my antennas, you know, 26 gauge maybe, something like that. I like the steel copper-clad wire that you get from thewireman.com. Very good wire, very strong. But I use other wires also, very thin. You know, I don't. Of course, you reduce your bandwidth a little bit, but it's not too much of a deal. All right. Any questions about portable stuff?
Okay, I guess if there are no more questions, Gil, thank you very much. Thank everybody for participating. And if there are no more questions, I'll close this thing up.
Very good. You guys go subscribe to my channel now. And thanks for having me. All right, guys. Yep, you have a nice weekend. How to build an RF choke? I just found it. Yeah, I have. Yeah, check my videos. It's all in there.